Okay, welcome back. Solution for problem 2. How to balance ionic equations, okay, in acidic conditions. Right, first thing to do is to separate the given equation into two half-cell equations and balance elements other than oxygen and hydrogen, okay. What I will do, I will split this into two. One solid zinc changes to zinc ion, zinc to plus aqueous, okay. And the second half is chromate, dichromate ion, and Cr3 plus. Okay, what will I do? I need to balance elements except then oxygen and hydrogen. This one I don't have to balance, I have to balance chromium, okay? The next step, according to the rules, is to balance oxygen atoms by adding appropriate number of water molecules to the opposite side of the reaction. Now, I have 7 oxygen atoms on one side, on the reactant side. I need to add 7 water molecules on the product side. By introducing 7 water molecules, I'm also introducing 14 protons, which has to be added on the opposite side, okay? The next step is to balance the charge, okay? The charge on the reactant side should be equal to the charge on the product side. Let's count. So plus 14 minus 2, that gives me plus 12, okay, plus 12, right? And I can write it here, okay. On the other side I have plus 6, okay. The charge of water molecules is 0. Now, to make plus 12 plus 6, I need to add 6 electrons on the reactant side, okay. So that the charge is now equal, is plus 6 on both sides, okay. After that, I can move on to the second equation. So zinc metal is oxidized to zinc 2 plus, okay. In this particular case, I just need to add 2 electrons, okay, to make them equal, to make the charge equal on the reactant side and on the product side, okay. The next step, we know that in the redox we have exactly equal number of electrons being transferred in reduction and oxidation. In that case, I would have to multiply this reaction into 3, okay, so that that will give me 6 electrons, which is equal to 6 electrons all in the other half-cell equation. Okay, having those two, I can add both of them to give me the overall equation, okay. So I need to add reactants to the of one half-cell reaction to the reactants of the other half-cell reaction, okay. So I would add 14 protons, okay. I also need to add chromate 2 minus 6 electrons will be cancelled, okay. Then I have 3 zinc ions, 6 electrons, again they will be cancelled, plus 2 chromium ions and 7 water molecules, okay. So this is the final equation, okay. This is the final answer. Now, let's move on to the more complex example. In this case, we have 2 polyatomic ions. Okay, 3 actually. So, first thing is again to split them, split the overall equation into 2 and balance them separately. So, the first one would be chloride. So, chloride. And the second one would be SO2. And SO4 2 minus. Okay, the first thing to do is to balance elements other than oxygen and hydrogen. We don't have to balance none of them, okay. In both cases, the number of chlorine and sulfur atoms is the same on reactants and product side. And the next thing is to add 3 water molecules here, and I need to add 6 protons here. And I also now need to count the total charge, okay? So plus 6 minus 1, that gives me plus 5 and minus 1 here. To make this plus 5 minus 1 equal to minus 1, I need to add 6 electrons, okay? Okay, I can move on to the second one. So 2 oxygens on one side, 4 oxygens on the product side. I would need to add 2 water molecules here. Okay, introducing 4 protons. I need to add them here. Next is to balance the charge. Charge on the reactant side is 0. On the product side is -2 plus 4 is +2. So I would need to add +2 electrons here as well to make it neutral. Okay, so I can split this 2. What else? I know that there are 6 electrons involved in first half cell equation and there are 2 electrons involved in the second. So I would definitely have to multiply this equation into 3. Okay, and after that I can add this equation to this equation to give me the overall net balanced ionic equation. Right, so let's do it step by step. So I have 6 water molecules plus 3 SO2, then 3 SO4 2 minus plus 12 protons plus 6 electrons. Now for that I will add this equation. Okay, right, so what do I end up with? Okay, 6H2O plus 3 SO2, okay, plus 6 protons plus ClO3 minus plus 6 electrons. Okay, on the product side, chloride, 3 water molecules, 3 SO4 2 minus plus 12 protons plus 6 electrons. Okay, 6 electrons can be cancelled. First of all, 6 water molecules, 3 water molecules is 3 water molecules. Now 3 SO2 plus 6 protons on this side. I can transfer them on the product side. Okay, so leaving ClO3 minus, Cl minus. We already counted 3 water molecules plus 3 SO4 2 minus and 12 protons minus 6 plus 6 protons. Okay, so that should be the final equation, the balanced final equation. We can check if we did this correctly if we count the charges. So what would be the charge here is -1 on the reactant side, -1, -6, -7 plus 6 is -1, okay, which is equal. Okay, thank you for watching.